Hi everyone, today we're going to talk about some more advanced stoichiometry, mainly discussing limiting reagent stoichiometry. When you bake a cake, you don't use all of your ingredients. For example, you don't pour in all of your flour and use all of the sugar you have in the house or all of your butter. And if you do without measuring, the cake's not going to come out well. Limiting reagent stoichiometry acts on the same principle. When you have a limiting reagent, you have more than you need of one substance to complete a reaction, but you have to figure out what substance you have too much of by converting using stoichiometry so that you can figure out if the reaction goes to completion. Just like baking a cake, measurements are involved in chemistry. Let's go ahead and start with an example. The reaction we have here is the combustion of methane. If you've ever lit a Bunsen burner, this is the reaction that happens. The question gives us 60 grams of methane and 110 grams of oxygen. And we need to find out which is the limiting reagent. Looking at the problem, it may seem like methane is the limiting reagent because we have less mass, but let's do some calculations to figure it out. To figure out whether we have enough of one substance, we start with any reactant and convert it to the others with stoichiometry. Let's start with our methane. Of course, if you want, you can start with oxygen and you will get to the same conclusion. We start with our 60 grams of methane and convert to moles. We then use our molar coefficients, or the molar ratio, to convert the moles of oxygen. We are given grams of oxygen, so then let's also use our molar mass of oxygen to convert to grams. When we complete the stoichiometry, we see that 60 grams of methane will react with 59.84 grams of oxygen. This means that there will be oxygen left over since what it will react with is less than what we have. Therefore, methane is our limiting reagent. Now, let's do two more advanced stoichiometry problems. We are now given the chemical equation for the formation of ammonia, a common household cleaner. We are given 34.5 grams of hydrogen and 39.6 grams of nitrogen. We are asked to figure out how many liters of ammonia at STP will be made, assuming the reaction goes to completion. We are not told whether a reactant is in excess, so we have to check for a limiting reagent. Let's start with hydrogen. Once again, we take the 34.5 grams of hydrogen, divide by the molar mass, use our molar coefficients. This time we have a 3:1 ratio of hydrogen to nitrogen, and then finally multiply by nitrogen's molar mass to obtain the answer of 159.95 grams of hydrogen. Here, you can see that even though we have less hydrogen, nitrogen is still the limiting reagent because we know that the hydrogen will react with more nitrogen than we actually have. So now, when we are calculating our product, we have to use nitrogen because there will be leftover hydrogen. Now, we have to remember where we are going. We are trying to find the volume of ammonia produced at STP. First, we take our grams of nitrogen that we are given, not what we calculated, and divide by its molar mass to get moles. We then use our molar coefficients to get from nitrogen to ammonia. It's a 1:2 ratio. Finally, we are asked for our volume at STP, so we multiply the moles of ammonia by 22.4 to get liters, and we get 63.27 liters of ammonia produced. Let's do one more practice problem. We are given the equation for the formation of sulfur trioxide. The question gives us 32.5 grams of sulfur and 65.2 liters of oxygen. Make sure you know that that's liters, not grams. We are then asked for the density of the gas produced if we have a 5-liter container at STP. The first important thing we have to remember is what density is. Density is mass divided by volume, and we are already given volume. So if we find mass, then we can divide it by 5 to get our density. First of all, however, we have to find our limiting reagent as the question does not give it to us. Let's start with oxygen this time. We have 65.2 liters of oxygen at STP, so we divide by 22.4 liters to get us to moles. We then once again use the molar coefficients in a 3:2 ratio of oxygen to sulfur to get moles of sulfur. By multiplying by the molar mass of sulfur, we get 62.21 grams of sulfur. Since the amount we calculated of sulfur is more than the amount we have, sulfur is a limiting reagent and it will all get used up. So we can proceed using sulfur in our calculations. We take our starting 32.5 grams of sulfur, divide by the molar mass to get moles, use our ratio of 2 sulfur to 2 sulfur trioxide to get moles of SO3, and finally, we multiply that by the molar mass to get 81.16 grams of sulfur trioxide. We then divide that by our 5 liters to get the density of our sulfur trioxide at this point, 16.23 grams per liter. That's all I have for you guys today. I hope this video helped you with some more advanced stoichiometry, and next week we will most likely start talking about thermochemistry. Thanks for watching, and I'll see y'all in the next one.